Hello, good morning, everyone. So, today we are going to discuss the leftover topics in the nerve physiology after we have finished from the yesterday's topic, insight in details. So, today we are going to start with the types of neuron. So, there is a difference between the types of neuron and classification of neuron. Let's start with the types of neuron. So when we are talking about the types of the neuron, it depends on the morphology, like how does it look, where the cell body is located, and overall, what is the function of that neuron with that particular type of morphology. Okay, so first is the unipolar neurons. Now, what is unipolar neuron? So, I think there was some issue with the connectivity. I think it's sorted out now. I think it's visible now. I think the connectivity issue is sorted out. So we start again. So we start with the types of neuron. When we are talking about the types of neuron, it depends on the morphology, the type of the neuron. Okay, now type of the neuron means where the cell body is located, where the axon is located, all this. So now I got a confirmation that the connectivity has been restored. Okay, nice. Okay. Yeah, good morning, everyone. Good morning. Who have joined? Yeah, Sethi Usman. I think the notes will be shared in Bhanusa's Telegram channel. You can subscribe to that and you will get all the notes. Jigar, Ambika, everyone. Good morning. So unipolar neuron, what it was, first it was thought that it is not at all found in human beings. It was only thought to be found in like insects and ants kind of organism, but later on it was again reported that no, it is also found in the human being, but which is like present in the mesencephalic in the mesencephalic neuron of the fifth cranial nerve. Now, how does it look like? Just an idea roughly for our understanding. This unipolar neuron, it looks something like this. Like it has got only one process, this one cell body kind of a thing that is taking out, and it has got like just one process. Okay, just one process. Now, through this process, one process, which is the dendrite. Okay, it is only through through this one process, both receptive, like reception of impulse, and secretion takes place. Okay, this is the unipolar neuron, which first was thought it is not present in human body, but then very latest study reported that we do have in the mesencephalic neuron cells of the fifth cranial nerve. Second is Telegram channel, if you subscribe to this Prosium our channel, you can always get it. Hanu sir has that one. So you just follow the Prosium channel, you always get the updates. Sir will give you all the notes there. Okay. The second one is the bipolar neuron. So this bipolar neuron is such that the cell body is like embedded. It is a part from which two different regions like extend out. Okay, two different regions extend out. Now this is the cell body, and this is like one part, like one goes to the spinal cord, right? And other part, it goes to the skin or muscle. Okay, it goes to the skin or muscle. Now, where is this bipolar neuron found? This bipolar neuron, example, they are mainly the sensory neurons that carries the sensation, like any kind of sense, like a pain sensation, a prick sensation, touch sensation. On those sensations are carried out by this type of neuron. Okay. Third one, which is also a type of a bipolar neuron, but again nomenclatured slightly different. It is nomenclatured as pseudo bipolar. Okay, pseudo bipolar. Now, why it is called pseudo bipolar? Because it is like structurally it is not like bipolar, but functionally it is quite like bipolar. So here the structure is something like this. Say this is the axon, and there is a like cell body which is sticking out, but unlike the unipolar, it has got two distinct processes. Two distinct processes. This is the cell body, and there these are the two distinct processes. Okay, so through one area they will receive and other area they will send out the impulse. Now this type of bipolar neuron, they are present in the dorsal root of ganglia. This is where they are located. Now comes the most common one, which is the multipolar neuron. Now, this multipolar neuron is like widely spread in the structures of the central nervous system. Now, this is the one whose structure we discussed yesterday. Remember, while drawing the structure itself, I was telling this structure is the most abundant one, but not the only one. Why I was telling that? I was telling for this reason. Okay, this multipolar neuron is the one that we largely study, the regular one. Okay, the standard one that we study, right? Which has got a wild, like well-defined cell body. Then it has got the axon. Then it has got this, like layers of this myelin sheath. It has got node of the Ranvier. It has got the dendrite, the dendron processes, right? And it has ultimately got the axon telodendria, which is also known as a synaptic knob. This is our multipolar neuron. Where are they found? Where is it mostly present? Now, these type of neurons, they are abundant, means in large number in the, like, hippocampus, then cerebellar cells, like the Purkinje cells, pyramid cells, all those cells, and cerebral cells also, but mostly they are abundant in the cerebellar cells. Okay, and then we know the function of all this multipolar neuron. Its main function is excitability. Now, this is the types of the neuron depending on what is the position of the cell body and its location. Another other type, not again classification, but type. Another typing of neurons is like, depending again on its shape, its diameter, and its function. They are Golgi tendon. Also, you can tell, okay, let's mention the tendon, because in some books it's mentioned, some books it's not. Golgi tendon neuron 1 and Golgi. You also find its mention as Golgi neuron 2. So I'm sure some of you have been have heard the name of this thing. Can you come up with the examples where this Golgi tendon neurons are found? Now, this Golgi tendon neuron or Golgi one type of a neuron, they are usually long. If you look at the morphology, they are like, something like this. They're long and elongated. So, they have this, they have long axons going in and out of the spinal cord. Okay, they are like long in structure and they go in and out of the spinal cord. Whereas the Golgi tendon 2 neuron, can you think of, you would have heard of it in the all the reflexes. Can anyone tell what kind of reflex, in what type of function did we study about this type of a neuron? Yes, it is inhibitory neuron. So when we talk about the inhibitory neuron, it will remind us about the reflex, the deep reflex that we call as the tendon jerk reflex. So whenever we stimulate, we pat on the knee, it will sway frontward, right? There will be contraction of the muscle and it will sway front. But the swaying, how far the leg will get extended, extension of the leg will happen, that there is a limit. That limit is maintained by this inhibitory neuron. That limit is maintained by the inhibitory neuron. Why so? So that the leg is not extended. The reflex is not like too much. It does not go too much front. Okay. So this is usually inhibitory, usually up to 98%. All this Golgi neuron type 2, they are inhibitory in nature. Okay, and morphological study reveal that they are star shaped. So we draw it for our understanding, and it turns out to be something like, this is the body, and it is shaped out like this. Okay, it has got a configuration like this. Okay, the star shaped branched out, and it is smaller in diameter, smaller in size also. This is what are the Golgi tendon neuron 2. So types we have studied. One is depending on the morphology, where the cell body is, where the receptors, the dendrites are, and where its location are. This is one type. Another typing is in term of the Golgi tendon neurons. Okay, these are the types of the neuron. Now, coming to the classification of nerve fiber. Classification of nerve fiber. Nerve fibers physiologically, nerve fibers physiologically nerve fibers are of motor type and sensory type. Okay, what do I mean? What do we mean by this? What we mean is that, sorry, I have scribbled it by mistake. I'm writing it again. So, what do we mean by motor type and sensory type? By this, we mean that some nerve fiber, their main function is to support or innervate, is to supply, is to innervate the muscle that is used for motor function. So what are the muscles for motor function? Motor function means for movement, right? Like we are moving the hand. Right now I'm moving my hand, my limbs, my fingers, right? For writing and typing it out. So, this muscle that are present in the limbs, and also for the posture, maintaining everything, those muscles of the limbs and the back, all these are for the motor function. Sensory function, there are certain nerve which when they get the firing, when they get the stimulus, they will make us feel the senses. What sense? Sense means like if a person got touched by something that is uncomfortable, pricky touch, or if the person has put his or her finger on a hot object or cold object, or has pricked the finger, or a person gets punched by someone, pushed by someone, all this, kind of touch, or there is a soft touch of a feather, all these things, these are the like manifestation that comes after there is firing from the sensory nerve fiber. Okay, so these are the type of the nerve fibers. Now, this type of this nerve fiber, there has been two type of classification. Now, the classification, the criteria for classifications, criteria for classification. Okay. First, the reported classification was done by the two scientists, Erlanger and Geiser. Classification by Erlanger and Geiser. Okay. So they took a bunch of nerve fiber which were both motor in function as well as sensory in function. Like the nerve fibers which were supplying the muscle spindles also, and also the nerve fibers which were sensing the pressure, pain temperature, change in the temperature, and a crude touch, soft touch, all those nerve fiber. They took them together and they classified it. Now, what was the classification basis? On what and how did they classify? They classified criteria for this classification was first was the myelination, like whether the nerve fibers are myelinated, do they have the myelin sheath wrap around, or they don't have it. Okay, that one, that is the first criteria. Second was the velocity of conduction of impulse through the nerve fibers. See, yesterday we studied, right? Myelin sheath is one of the important factor for determining the speed of the impulse, speed of the current that has to be conducted through the nerve fiber. So if there is myelin sheath, the velocity faster will be the impulse that is conducted, right? By saltatory conduction. If the myelin sheath is less or if it is absent, the speed will gradually become slower. So the velocity of conduction, this is second factor. Third factor is the diameter of the nerve fiber. Now, this is also another factor that we studied and understood yesterday, one of the important determining factor. Now, depending on this, they chose the classification into alphabetic order. Okay. The classification has been done as A, B, and C group of nerve fiber. So, let's go through it. How was the classification and what is the classification? So, see, this is the nerve fiber type. Let's write the diameter first. It will be easy. Diameter in micrometer. Okay. Velocity. Okay. In meter per second. Then we write its location in context to function. Okay. So here we will mention for what sensation is it sensitive, or what it is actually sensing. Okay. So here the nerve fiber type A alpha. Now this A by this Erlanger and Kaiser, it has been nomenclatured into subtypes. A alpha, beta, gamma and delta. And remember Erlanger and Kaiser, they classified both motor and sensory nerves. Okay, nerves or nerve fiber, neuron, they mean all the same, both. So A alpha. Here, this A alpha, they have this one. This is myelinated. It is not only myelinated, it is very heavily myelinated, very thickly myelinated. The A alpha, myelinated thickly, okay, very thickly myelinated. Now, here the diameter of this is about 70 to 120. And the velocity at which it conducts, it's like really fast. The velocity is about like more than 50 to 70. At that speed it can conduct. Now where is it located in context to its function? It is mainly for the proprioceptive function, like feel of the pressure, feel of the location of the movement. Okay, that is a proprioceptive function. Second we have is the A beta. Now this is also myelinated. It is very good myelinated but little less thick compared to that of this A alpha nerve fiber. Okay, so here the speed is somewhere between like 70 to 50. Okay, and the diameter is about 25 to 40. Like this is the diameter and this is the speed, like 25 to 40 meter per second. And in context to what it is sensitive, like what is it sensing? It is sensing mainly the pressure, the touch sensitization. Okay, now these two are mainly sensory in function. Next comes the A gamma. The A gamma, this is also myelinated. Okay, but it is again lesser than that of the A beta nerve fiber. The myelin sheath are not as thick as the A beta type. So since it is not as thick as that, so obviously the diameter will also be less, right? The diameter will also be less. Here the diameter is usually less than 25, less than 25. And the conduction of the velocity, it also falls. The conduction of velocity is also less than 20. Okay, and this one actually does the motor supply to the spindle. So this has got the motor function. Okay, in A, the last subunit that we have is the A delta. Now this one is slightly myelinated. It is not very heavily, it is lightly myelinated. It is lightly myelinated. So here the conduction velocity falls even less. It is less than, like, the diameter is like less than 12. The conduction velocity is less than 13, and what it senses is pain and pain and touch. It also senses pressure to some extent. Okay, these are the alpha type of nerve fiber. Then comes the B type of nerve fiber and C type of nerve fiber. So B type of nerve fiber and C type of nerve fiber, both are unmyelinated. These are unmyelinated. These two are unmyelinated. So obviously if it is unmyelinated, the diameter is also, here the diameter is like less than 3, and here it is somewhere between 0.2 to 1 or like 1.2. that much. And it is like very, very slow. The velocity conduction is like very, very slow. It is like less than 4, and here it is like less than 1.5. It is very, very slow. So where it is located, this in context to the function, this is the preganglionic nerve fibers, and they are mainly the dorsal root and the sympathetic postganglionic fibers. So from the above classification, what is the take? If we try to correlate with what we studied yesterday, we can say that A alpha has the highest speed of conduction of impulse, whereas the C, which is the unmyelinated nerve fiber, C has the least or slowest speed of velocity of impulse conduction. Okay, this is our take. This is something we have to remember from what we studied. A alpha has the highest speed, and the C unmyelinated fiber, it has the least speed. Okay, this is what was the Erlanger and the Geiser mode of classification. Now, apart from that, there is another classification that was reported, another classification that was done. The second classification was done by Lloyd and Hunt. Okay, Lloyd and Hunt, that's the classification. But unlike Erlanger and Geiser classification, what they did, they classified only the sensory nerve fibers. Like, they have taken the nerve fiber that has already been classified and reported according to the Erlanger and the Geiser. So that from that nerve fiber, what they did not classify the motor nerve fiber, that they opted out. They took and they classified only the sensory nerve fiber. So, and also one more thing, instead of using A, B, C, because it was already used by Erlanger and Geiser, they used the numerical, like the numerical, the Roman numerical, and reclassified the Erlanger and the Geiser. Okay, so according to that, what stands out is like A alpha, it is classified into 1A and 1B. A beta has been classified into Roman 2, and both this they sense the pressure. Why do they sense the pressure? Because 1A, it supplies the muscle spindle, and 1B supplies the Golgi tendon. Now A beta is like the 2. It also senses touch and pressure. Okay. Here, A gamma, since it has only motor function, that has not been taken. A delta has been classified as 3. And what does it sense? What does it sense? Look here. A delta, it senses the pain and the touch. And when we call pain, when we classify pain, pain also induces pain by the temperature receptor. So pain and cold receptors. Okay, because sometimes cold and heat, which is too much more or less than the body temperature, also induces the pricky sensation. So pain and cold receptor. B again, you see, it is the preganglionic nerve fibers, right? So it is not having any sensory function. So this is also not included in the Lloyd and Hunt. But the C, it has got sensory function and it is sensitive to pain and temperature, because it is both the sympathetic postganglionic fibers as well as the dorsal C root neurons. So they can sense the pain and the temperature. So here you see the Erlanger and the Geiser's classification has been again reclassified, taking only the sensory nerve fiber. Coming to the physiological agents. Now all these fibers like this A, B and C, talking about the Erlanger and the Geiser's classification, depending on susceptibility to physiological agents. The classification is, okay, depending on the susceptibility to the physiological agent, the classification of this ABC are like nerve fiber, which is like in most susceptible to less susceptible condition, like hypoxia. This is a condition that happens every now and then in the cell, because suppose we are confined in a place with 10 people, then also we are not having enough oxygen. If we are not having, if you're not breathing enough oxygen at the tissue level, through the blood, there will be less oxygen delivering to the cells. Okay, so whenever there is, or if we are like working out, we are doing a metabolic activity, or we are like running, or we are having any kind of physical activity, that time also the metabolism in the cell increases, they use more oxygen, so there is always a oxygen deficit. So any condition that leads to deficiency of oxygen at the tissue level, that is hypoxia. So just writing the definition for a quick grasp. Okay, it means deficiency of oxygen at tissue level. Types of hypoxia and all we will do when we are doing the respiratory system. So always remember, deficiency of oxygen where? Not at the level of the lungs, not like when we are not able to get enough oxygen to breathe in, not that one, but when there is inadequate oxygen, not enough oxygen in the tissue. Okay, that is called the hypoxia. So in this condition, this hypoxic condition, which group of this nerve fiber will sense it first? It is the B. B has greater susceptibility than A, than C. Okay, so all this will actually sense, all this nerve fiber will sense the hypoxic condition, but the B group will sense it first, then the A, then like it is like after that it will be sensed by the C nerve fiber. Okay, second situation is the pressure, and third is local anesthesia. Like for many small surgery on the surface and all, we have to do local anesthesia, right? So in both this condition, the most susceptible nerve fiber which will sense this two condition first or in a very speedy manner is A. It is faster than B, and B is faster or more susceptible than C. So for pressure and local anesthesia, the hierarchy is ABC, and for hypoxia it is BAC. So these are the total 5 ways of different type of neuron. First we have studied the types, and then we studied the 3 type of classification of the nerve fiber. Okay, moving on to the nerve injury. Now, what is a nerve injury? In our day-to-day life, there may be a situation when a person is exposed to some kind of a trauma. Trauma here in case of this nerve injury, it means that here the nerve is has either like faced an accident, or due to some reason there has been a fracture of the bone. Guys, hold on. I can see a technical issue here. Okay, so I'm just going for a break because what I'm writing, it's coming very, very slow. So I'll just get back to you. 1 second. There is a technical hitch in it. A technical issue. 1 minute. No, okay, it has been sorted out. It's actually the lag that is being created. Hello? I'm going. I think it's issue resolved now. Okay. Okay, it has been resolved. There was something in the net connectivity issue with the net connectivity. Okay, now coming to the nerve injury. When does a nerve get injured? Like as I told you, like in day-to-day life, there may be a condition that a person has a fracture of the hand or a leg or any bones. Or there may be some kind of traumatic, like, there can be trauma that has been resulted from a fight, from a punch, or some kind of issues. Okay, so in all this condition, nerve get injured. Now, the injured now the life injury, the injury of the nerve, like what degree it is and how much what it is happening, it depends on which structure of the nerve fiber has gotten ruptured. Okay, now say for example, let us go to the diagram. This is our neuron. This is one nerve fiber with a cell body, myelin sheath, and the synaptic knob. Now, there may be injury that may only affect the myelin sheath, and it will not affect the axon, the cell body, or anything. And there can be also serious type of injury that may result from some fight between two person, or some kind of a road accident, or anything that has affected the hierarchy of the nerve fiber. Hierarchy means the connective tissue layers, like the endoneurium, perineurium, epineurium, all those connective tissues. So, depending on how much the nerve fiber has got distorted or damaged, there has been a classification. Now, here also there is like two type of classification. The first classification was done by Seddon. It's called Seddon's classification. So, Seddon classified the nerve injury, like injury, only into three types. Only into three types. The first type is neuropraxia. Okay, it is the first type of the nerve injury, and this is the least severe form of injury. Like, here what happens? Maybe like there has been a blow or a punch. Okay, this results in this type of injury. So here actually what happens is, here only the conduction of impulse may be temporarily blocked. Okay, only for a little bit of time, the conduction of impulse may be blocked. Why this happens? This may happen, say, this is our nerve fiber, okay, one neuron. Say there has been an injury, there has been a trauma, but this trauma is not very severe. Only the myelin sheath, only the myelin sheath, just little bit here and there got like ruptured, little bit, not distangled or anything, little bit it would have got rupture, but the axon is intact, the endoneurium is intact. So here, due to compression, neuropraxia means pressure. Due to pressure, here only there has been little bit of damage, only little damage to the myelin sheath happens. So temporarily there is stoppage in the conduction of impulse. It swells up and the person cannot feel any conduction. For time being, the mobility in that swelled up area is stopped. But soon it is the least severe form. Neuropraxia gets corrected within minutes to hours. Okay. Now the second classification, the second type of injury, that is the axonotmesis. Now here the nerve gets crushed. In praxia, the nerve got compressed. Here the nerve gets crushed. So when the nerve gets crushed, what happens is, there is this ruption to the axon. If the axon is disrupted, it will obviously mean the myelin sheath is also distangled. Okay, distangled or damaged. Okay, this is what it means. Here, Wallerian degeneration occurs. Now, what is Wallerian degeneration? This is our next topic. Okay, so here Wallerian degeneration occurs. Its recovery may take up to several days to week, and in rare cases surgical intervention is needed. So another thing that happens is there here the endoneurium may be affected. This is what Seddon has told. It also may be affected. Meaning what? In this type of injury, I can drawing it. Okay. So here you see if this is the nerve fiber and this is the axon. Okay. This is the axon and this is the myelin sheath obviously. Okay, myelin sheath. So here actually in case of axonotmesis because of the crush injury, this is the site of the crush, this is the site of crush. So what may happen is that there may be disruption of this myelin sheath as well as there may be disruption or damage to the axon also. Okay, this is what happens when there is crush injury. Okay, apart from that, yesterday we studied the hierarchy. So if this is the axon, the outer covering is the endoneurium. The outer covering is endoneurium, right? And many such forms a fascicle. So this is the endoneurium. Now many such is enclosed by the perineurium, and then many such is enclosed by the epineurium, right? This is what is a hierarchy. Now in case of this axonotmesis, what happens here? In some cases the this endoneurium, it may be damaged. Okay, but the epineurium is intact and the perineurium is also intact. So perineurium and epineurium, they are intact. Only the endoneurium may be damaged in some cases. That is the Seddon's classification. Okay, the older one, the older one. Third, it is neurotmesis. Now, neurotmesis means transaction or total cut injury. Out and out cut injury. Now, this is the most severe form of injury according to the Seddon. It is most severe form of injury. It obviously needs surgical intervention. Okay, and here all the epineurium, perineurium, endoneurium are disentangled. Now, such type of injury only occurs when a person's something gets amputated or like totally cut. Like if there is a saw that is run over a person's limb or something, then this kind of injury is seen and it needs surgical intervention for sure. Because here all this three, like if this is the endoneurium, this is the perineurium, and this is the epineurium. So endoneurium, perineurium, and epineurium, all these three, they get totally damaged, totally disentangled. Okay, this is the Seddon's way of classification. Now, Seddon's way of classification was further modified and classified by Sunderland, and this is what is into practice today, like which is like studied these days. It is called the Sunderland's classification. Okay, Sunderland's classification. So, what Sunderland done is he took this same classification like what Seddon has taken or Seddon has done. He has taken this same classification but in a slightly modified way, and instead of three classification he further pushed it to like five classification, and he mentioned those as degrees, mentioned those as degrees. So according to the Sunderland's classification, the first one is the first degree. Okay, it is same as neuropraxia. Okay, totally same like that of neuropraxia. The first degree of nerve injury according to Sunderland is same like that of the neuropraxia, means it is very least, it is slight, only the myelin sheath is disrupted little bit here and there, and there is only stoppage in the conduction for a little bit of time. Okay, and it is said that it happens due to ischemia or compression. Okay, these are the two reasons. This is the first degree. Okay, second degree. So according to Sunderland, second degree, it is same as Axonate, axonotmasis. The same as axonotmasis. Here, like Sunderland added, here the recovery rate is like 1 to 3 millimeter per day, and Wallerian degeneration happens. Okay, Wallerian degeneration happens. The third one, is the third degree. What is the third degree? It is axonotmasis in which endoneurium is affected. It is the axonotmasis in which the endoneurium is affected. And here also Wallerian degeneration occurs. Okay. Fourth is the fourth degree. Okay. Here it is same as axonotmasis in which the axon endoneurium and perineurium is affected. Only the epineurium is intact. So this is like a severe form. It is intact. Only the epineurium is intact. Okay, only epineurium is intact. And obviously, here, surgical intervention is required. The fifth one is the fifth degree. Fifth degree of injury. Let me write it a bit clearly. Here, it is same as neurotrophins. Whole of the endoneurium, perineurium, and neurium are dismantled. Like the whole hierarchy, the whole formation is like destroyed. It is affected. Okay, this is the fifth degree. And here, surgery is the sorry only option. So this is our classification of the nerve injury. Okay, moving on to degeneration and regeneration of a nerve fiber. So degeneration and regeneration of nerve fiber. Okay. Now, what is the meaning of degeneration and regeneration? Degeneration means the destructive changes in the structure and function of a nerve fiber. Now, in context to this degeneration, let us remember one thing. The degenerative changes are mainly the structure. So, when the structure of a nerve fiber is like destroyed, its orientation is hampered, obviously it will affect the function. But degenerative changes first means the structure, eventually that will affect the function of a nerve fiber. Okay, so this is the degenerative changes. So what is regeneration? Regeneration, it means these are the this are the reparative changes that occurs following means after, following a nerve injury and degenerative changes. Sorry. Okay. A little bit more insight into the regeneration. So regeneration, it is the reparative form, right? It is the reparative changes. This regeneration, so this is like little bit insight to the regeneration. So I'm putting it in the third bracket. This regenerations occur in the peripheral nervous system nerve fibers. Why so? Because they have the Schwann cells. Okay. Then why the central nervous system, the regeneration does not happen? This is so, like, whereas in central nervous system, the oligocytes lay the myelin sheath, not Schwann cells. Okay. As a result of which the oligocytes or the oligodendrocytes, they cannot lay the myelin sheath. Apart from that, other reasons for loss of regenerative capacities in CNS neurons. What are the other reasons? The other reason is that any injury or trauma of the brain causes proliferation, like increases the number of oligodendrocytes and induces inflammation. Okay, so it induces inflammation and it also proliferates the oligodendrocytes. So all this together creates an environment. All these stops regeneration in the central nervous system. Okay, this is the reason which has been reported many times in all the reports, and also it is found in all the books. Now, some recent study also comes up with some or proposes with some other theories. Okay, recent study says that receptors like NOCA receptor or like OMG protein, oligomyelin gangliosides, all this thing, and glycoprotein and certain other glycoproteins inhibit the CNS degeneration. But this theory has not been proven yet. Okay, so these are the reasons where there is no proliferation of myelin sheath further or laying of the myelin sheath regeneration in the central nervous system neuron. Coming to the process of the degeneration and regeneration. So, the process and steps involved in degeneration. Okay, first degeneration. Going by the diagram, it is like this. See, this is our cell body of a neuron. This is our axon. This is our synaptic knobs. Okay, and these are the myelin sheath. Okay, these are the myelin sheath. We also have this nasal granules, right? And dendrites, all this thing. Say, now suppose the site of injury, say this is the site of injury. This is the site of the injury. Now, the portion that is above the site of injury, it is called as the, this area is called as the proximal region, and the area below the site of the injury, it is called as the distal region. Okay. Here, the degenerative changes that happens in the distal region, the direction is like this. Okay. And the one that happens in the proximal region, the direction is like this. So here you see the changes, the degenerative changes, it is like away from the cell body towards the synaptic knob. So from the body, away from the body. So this is called the anterograde degeneration. Okay. Whereas here the degenerative uh, position, like in the proximal region, the degeneration happens from the axon towards the cell body, that is going like towards the cell body in the opposite direction. That's why it is termed as the retrograde degeneration. Okay. Now this anterograde degeneration is also called as the Wallerian degeneration. This anterograde degeneration is called the Wallerian degeneration. So when the Wallerian degeneration sets in, what are the changes that happens? Changes in Wallerian degeneration. What are the changes happening in the Wallerian degeneration? First and foremost thing that happens in the Wallerian degeneration is the myelin sheath gets damaged. Okay. The axon gets dismantled. It gets dismantled. Okay, the dismantling of the axon happens. Now, when this myelin sheath gets damaged, how does it look? Like near it, side by side, I'm drawing. It will be easy to understand. So, myelin sheath damage, it will look something like this. Like there will be like wearing of this myelin sheath, like this. Okay, like this. This myelin sheath will just wear off. And myelin sheath, if we draw, we know that myelin sheath, it is rich in lipid and it is very little in protein. So if this orange lines, if these are the protein, say for our understanding, this is the lipid of the myelin sheath, the lipid portion of the myelin sheath. Okay, see this one, these are the lipids. So this lipids will come out. There will be histochemical changes like the lipid will precipitate into oil droplets. This lipid eventually they will precipitate as oil droplet. Next, the Schwann cell that laid the myelin sheath, right? Because it's a myelinated sheath. The Schwann cell will act as macrophages. So there will be like this, this macrophages that will appear. The Schwann cell, it will act as the macrophages and will clear up the debris. Okay, these are the major changes that will happen in the distal portion. One thing, another important thing to remember, the neurolemma will remain hollow but not get damaged. Okay, this is a point to remember. It will remain hollow, what? The neurolemma, but will not get damaged. These are the changes in the distal portion, which is the Wallerian degeneration. Now, what will happen in the proximal portion? Proximal portion also, there will be the first phenomena which we call as chromatolysis. I will draw here and then we will understand what is chromatolysis. So if I draw this again, so chromatolysis means you see chrome. When you see under the microscope, there will be this purplish stain that will be seen under the microscope, which will mean the nasal granules of the cell body of a neuron. Now, what are the nasal granules? Nasal granules, so these are the nasal granules. Okay, one second, we'll come back to that. Now, what the changes in the proximal, or rather, let's write degenerative changes in the proximal part. Okay, so here, first thing will happen is chromatolysis. What is chromatolysis? It is disintegration of nasal granules into dust particle. Now, what is the nasal granule? Nasal granule is the rough endoplasmic reticulum that is present in the neuron. And here the ribosome is in rosette form, right? Instead of the linear form that we see in the peripheral cells. So nasal granule will disintegrate into dust. Second thing that will happen is the cell body will draw fluid from the surrounding and swell up. Next, the nucleus will be pushed to the periphery. Okay, the nucleus will be pushed to the periphery, and Golgi apparatus, mitochondria will get disrupted. Like they will get fragmented and they will get disrupted. So if we draw the picture, it will be like that. This neuron, it will just swell up by drawing like lots of water. Okay, and the nucleus will be pushed to the periphery. It will be pushed to the periphery, and then there will be no appearance of the nasal granule, a thing which is a phenomenon which is chromatolysis. This is how the cell body will disintegrate, and the cell organelles like the Golgi bodies, like the Golgi bodies, the mitochondria, all these things that they were present, they will all disintegrate. They will get fragmented and they will disintegrate and they will not be seen. These are the degenerative changes. Now, after degenerative changes, one point to remember is this. Here, the degenerative changes occur 24 to 48 hours of injury. Okay. After that, in peripheral nervous system neuron, regeneration occurs. Now, what are the regeneration steps? First thing, it starts within 96 hours of degeneration. Okay, what it starts with, the first thing that happens in the regeneration part is that myofibrils, about 50 to 100 in number, come out as sprout. Okay, so say this is the damaged axon in which this myelin sheath, the myelin sheath and all has been damaged and disintegrated. From there, when regeneration starts, there are about like this sprouts. Okay, the sprouts of this myofibrils, this various sprouts of this myofibril, they will start appearing. they will start appearing. Okay, like this. They will start appearing. Now, out of such 50 to 100 myofibril sprouts. Now, out of such 50 to 100, only one myofibril will invaginate the neurolemma. It will invaginate the neurolemma, and ultimately there will be like again laying of myelin sheath, and myelin sheath will be laid. On the proximal side, what will happen in the proximal side? The nucleus will come back to its center, and Golgi apparatus, mitochondria, and rough endoplasmic reticulum, that is the nuclear granule, will reappear. Okay. What is the sign? What is the positive sign for regeneration? Like if tapping is done on the site where regeneration has to occur, if there is this tingling sensation, presence of tingling sensation over the area of regeneration indicates regeneration. Okay, and this is Pinel's sign, or we call it positive Pinel's sign. Now, what is the applied aspect of it? The applied aspect is that if the gap between the cut areas, that is proximal and distal area, is greater than 3 millimeter, even if it is in the peripheral nervous system nerve, even if the person is a young healthy individual, then regeneration goes wrong. Okay. In that condition, what happens? See, if the cut area, it is like if this gap, say this is the cut area, this is the cut site or the injury site. If the gap is less than, is greater than 3 millimeter, then what happens? There is only formation of the like tangles like that. Okay, there is like offshoot of the tangles. There is no sealing of the gap. There is no sealing of the gap. Let me draw it in a better way. It will be easy to remember. So, if these are the, it is the site of injury. It may be cut injury transaction, whatever, and gap is greater than 3 millimeter, then what will happen? Even if there are this myofibril sprouts, okay, still there will be no laying of the myelin sheath. This gap between the two cut end, it will persist. It will persist. So if this happens, there will be, this will result in wrong perception of touch sensation. Suppose there has been a cut in the toe, under the toe of the person, and the cut is such that the gap is more than 3 millimeter. So there will be no laying of this nerve fiber again. That gap will persist. So sometimes it happens if that person's great toe is like touched or tingled, he or she might feel that the little toe is being tingled. So this is the wrong perception of the touch sensation. Okay. And the gap, the physical gap is called as neuroma. Is called as neuroma. Okay. The thing we have to remember. Moving on to the neurotrophins. Neurotrophins. What are the neurotrophins? Neurotrophins are basically protein in nature. They are what? They are the proteins that are needed for survival and nourishment of the nerve cells. Okay, they are needed for the nourishment and the survival of the nerve cell. These are these are secreted by the astrocytes, the star-shaped supporting nerve cells. These are the astrocytes. So it is the astrocyte that secretes and synthesizes this neurotrophins. Neurotrophins are of following types, which is called as nerve growth factor, and it uses tyrosine kinase A receptor. Okay, next one is brain derived neurotrophin factor, abbreviated as BDNF. It uses tyrosine kinase B receptor. Other important type is neurotrophin 3. It uses tyrosine kinase C and tyrosine kinase B receptor. Then we have neurotrophin 4 and 5. These are the most common type of neurotrophins. Okay, these are not only the only type of neurotrophin, because neurotrophin are essential for the development and nourishment, right? For the survival nourishment, it is needed. So neurotrophin 4 and 5, it uses the tyrosine kinase B receptor. Okay. Now, other type of neurotrophin are the types of neurotrophins. What are the other types of neurotrophins? They are like ciliary derived neurotrophin factor. Okay, C, D, and F. Then we have glial cell line derived neurotrophin factor G, D, and F. Then we have platelet derived growth factor P, D, E, F. Then we have insulin like growth factor, which is IGF. So these are the common type of the growth factor. Now, all these, all the above mentioned growth factors, they enter the nerve fiber by endocytosis. They enter by endocytosis, and they are all growth promoting factors for the nerve fibers. Okay, and they also aid, they also help a lot during the regenerative process. Now just we'll discuss about the location of the few essential nerve growth factors like nerve growth factor or NGF. It is found in the sympathetic and cholinergic neurons. Okay, rather should not say found, it is required. Okay, by the sympathetic and the cholinergic neurons, especially and also in the basal ganglia. Okay, what is the clinical link here? In immunosympathectomy, anti-serum antibodies are raised against nerve growth factor, which destroy the whole sympathetic ganglions. Okay, this is the nerve growth factor. Second, we have brain derived neurotrophin factor. So, it is localized because it is used mostly by the vestibular ganglion and peripheral neurons. The clinical link here is, we have seen that this brain derived neurotrophin factor, it uses the tyrosine kinase B receptor, right? It is seen to be non-functional in people suffering from clinical depression. So people who suffer from clinical depression, here the brain-derived neurotrophin factor is seen to be disturbed. It is seen to be inadequate. Either the tyrosine kinase B activity is disturbed or the level, that means the quantity of this growth factor is less in the clinical depressions. Okay, so these are the conditions. Next is Next is the neurotrophin 3. So this is located in the mechanoreceptors to the skin, whereas neurotrophin 4 and 5, neurotrophin 4 and 5, these are more in the sensory neurons. Okay, these are more in the sensory neurons. They need for the survival and the growth of the sensory neurons more would be T. And next we have the real cell derived neurotrophins. These are more in the spinal motor neurons, whereas the ciliary neurotrophins they are abundant in spinal cord neurons. So these are the few examples of this neurotrophin, how and where they are located. Okay, and this is absolutely essential for the growth, for the survival, and also they take active part in the regeneration of the nerve fiber. So today in the second part, we have understood about the nerve injury. First, we started with the types of the neuron, classification of the neuron, nerve injury, what are the degenerative and regenerative changes in the nerve injury with the diagram and the explanation in details and also the neurotrophy. So as in the first day itself, we have told that this lecture will be taught totally in detail so that you know each and every minute details in the concerned subject. So here we complete the nerve physiology in total minute details. So from tomorrow, we would be starting the muscle physiology. Okay. See you all tomorrow then. Bye. Thank you.